Hi everyone. Today we are going to start with the chapter Triangles. It is one of the major chapters with respect to geometry in class 10th. Okay. And the topic over here, though triangles, yes, you are well aware of that. But the topic that we are going to deal in this chapter is similarity of triangles. And that is absolutely new. Okay. So let's quickly start with what is triangles and what is similarity of triangles basically. Okay. When we are talking about similar triangles, it is different from congruency. Okay, we will compare with congruency in the next slide. But first, let's understand what is similar. As literally, when we speak in English, similar figure, right? If we say something is similar, we are not saying that it is exactly equal, right? We say that yes, by appearance, it looks similar. That is what we mean always in English, right? So when we are talking about similarity of triangles also, there are two things that you have to deal with over here. The first one is the sides, the corresponding sides are supposed to be in proportion. Suppose corresponding sides in proportion. They are not supposed to be equal, but they are supposed to be in proportion. I will explain that with the help of an example. And the second criteria is corresponding angles are equal. Okay. So the two criteria is that when we are talking about similarity of triangles, first, the sides, the corresponding sides are supposed to be in proportion. Second, the corresponding angles, they are supposed to be equal. Now, I'll just make a figure over here. ABC, the first triangle, and then we have PQR. Okay, I'll say this angle is 30. This is 30, right? This is 6. This is, I'll take 70, 70. And then we have 80 over here. Obviously, the third angle is left out is 80. Now, all angles are equal. When we're talking about the sides, let's say this is 2, okay, this is 3, and this is 4. So the corresponding sides, the two triangles ABC is going to be similar to PQR only when all the sides are in proportion. So for that matter, if I say this is 4, this is supposed to be 6, this is supposed to be 8. Every side has got doubled. What I have done, just check the ratio. If I do AB over PQ, what do I get? 2 over 4, that is half. And if I do AC over PR, I am having 3 over 6, again half. And similarly, if you do 4 over 8 for the third side, that is also 1 by 2, right? That shows that all the sides are in proportion. Okay, we are not talking about equal sides over here. We are talking about sides being in proportion. That is similar triangles. So the corresponding sides are supposed to be in proportion and the corresponding angles are supposed to be equal. Okay. Now, let's understand what is the difference between similarity and congruency. Because by now, you are well versed with congruency, which you had dealt in last year. But now, we are going to deal with similarity. So it is very important to understand how they both are different. As we have just learned, similarity means the corresponding sides are in proportion. But when we talk about congruency, the sides are supposed to be equal. That is what we have been doing always. We've always equated the sides when we were proving the congruency, right? Sides are equal. The second, angles. Yes, angles are supposed to be equal, and that is same for congruency as well. So what actually differs? The difference lies only in terms of sides. The sides are not supposed to be equal, but in proportion. Whereas in congruency, the sides are supposed to be only equal. We do not have to worry anything with respect to proportion in congruency. Okay, so that is the major difference with respect to sides. Okay, now when we talk about similarity, the first and the foremost important thing is BPT, which is also called as Basic Proportionality Theorem. In short, it is written as BPT, and it is also known by the name Thales Theorem because of the mathematician Thales, who actually taught us about this theorem, right? Now, what is it about? Let's read the theorem. I have taken an excerpt from the NCRT. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. See, we are talking about similarity, so we will always talk about the ratio, the proportionality of the sides. Now, before we start with the understanding of the theorem, just see what I have also copied down over here. It had appeared in CBSE 2002 compartment, 2005, 2006 compartment, 2007, 8, 9, 10, and I have just written till 10. But it has been appearing in the board exams almost like every year. So that can actually make you understand that how important it is, how important not just the theorem, but we have to understand the proof. The proof appears in the boards. Okay, not just the theorem. Theorem, no one will ask you to write as it is, but the proof that comes in your final exam. And obviously, when we are talking about boards, internal exams are included. Okay. Now, let's decode the theorem, what exactly it was saying in simpler words. I have made a figure already on the screen, but I will be redoing the figure while explaining. If a line is drawn parallel to one side of a triangle, first, let's make a triangle. Okay. Then they're saying if a line is drawn parallel to one side of a triangle, I have drawn these two sides parallel, right? Okay. To intersect the other two sides, yes, it is intersecting. So let's name the points. A, B, C is our triangle, and we have drawn DE parallel to BC. So now the line DE is actually intersecting AB in D and AC in E. This is what I have done over here also, right? Then the theorem says the other two sides, that is, we are talking about now, other two sides are AB and AC. Okay. The other two sides are divided in the same ratio. Okay. AB and AC are divided in the same ratio by the points D and E, because we drew a line DE parallel to BC. So those points D and E are actually dividing the two sides AB and AC in the same ratio. Basically, they are saying that AD over DB has to be equals to AE over EC. This is what they are claiming. Are we clear with it? So what exactly they are saying? They are saying to prove that AD over DB is supposed to be equals to AE over EC. Right? Now, we have understood what needs to be proved. So we are going to start with proving it. That is, we will learn how to prove BPT, Basic Proportionality Theorem. Okay, this is the figure that you can see over here. And I have drawn few extra lines. They are part of the construction. Okay, so I'll explain what I have done. This was to prove. Okay, now when we talk about construction, we will write join BE and CD. After that, what I have done, draw EM perpendicular to AD, or you can write AD even, and then DN perpendicular to AE. Okay, so we have drawn four extra lines. First, we joined BE and CD, and then we drew two perpendiculars from DN being perpendicular to AE and EM being perpendicular to AD. Okay, because they are going to be used. Now, let's start with the proof. Okay, now when we talk about the proof over here, we first find out the area of triangle ADE. Okay, area of triangle AD. I'm talking about the upper triangle ADE. Okay, we are going to learn the area of triangle ADE from two perspectives. First, let's consider AD being your base. Okay, if AD is my base, that means EN is the perpendicular, right? So what is going to be the area? It is going to be half times AD into EN. The formula for the area of a triangle is half base height, right? So I have written base as AD and height as EM because we drew a perpendicular, right? So perpendicular means it's the height. Now, we will again talk about the same triangle's area of triangle ADE. And now you have to consider AE as your base. Okay, so when we take AE as the base, the area becomes half into AE times. Now, if AE is the base, DN becomes your perpendicular. Okay, so it is going to be AE into DN. Right? This is what we get. Now, next. Again, we are going to talk about the area of triangle BDE. Now, BDE means we are talking about this triangle. And if you see, BDE is an obtuse triangle. Okay, it is an obtuse. This angle is an obtuse over here, right? It is stretching like this. Okay. Whenever we have got an obtuse triangle, the altitude, that is the height of that triangle, falls outside the triangle. It was taught to you in class 7th. And 100% children actually forget this by the time they are in class 10th. Okay, I'm going to explain that over here. See, this is the kind of triangle we have. So when we are supposed to draw the height from this point that I'm highlighting, the altitude will move out of the triangle, and the base you have to consider, this was the triangle DBC. So BD is your base, then the altitude is the line which is lying outside. Okay, so when we are talking about triangle BDE, the formula, the area becomes half into BD and the altitude is going to be EM, right? So I'll write half into BD into EM. Okay. Now, after that, area of triangle CED. Now, which triangle are we talking about? CED. We are talking about this triangle. Again, this is an obtuse triangle, right? This is an obtuse triangle of this sort, right? So now, if my base is EC, the altitude goes over here. Just a second. If EC is my base, the altitude is DN, right? The altitude is DN because that is actually kind of lying on the extended base. Okay. So that is half times EC times DN. Okay. So what we have got till now, we have got 4 areas, 2 areas of the same triangle ADE, considering 2 different bases. And then we found the area of 2 obtuse triangles, that is BDE and CED, right? Now, we need to understand one more theorem over here. That is a new theorem actually, and we need to use that over here. You guys haven't studied it ever, so I'm just going to write it properly. When 2 triangles lie between 2 parallel lines and are from the same base, they are equal in areas. Okay. The theorem says when 2 triangles lie between 2 parallel lines, which lines do we have parallel over here? We have got DE parallel to BC, right? And the two triangles that we're talking about over here is BED and ECD, right? They are lying between the same parallel lines, and they are also actually originating from the same base, that is DE. Okay, so when they are originating from the same base, they are supposed to be equal in area. So what are we going to do over here? That means the area of triangle BED is going to be equals to area of triangle CED according to this theorem, right? So let's do that. So what do we get? We get area of triangle BED equals area of triangle CED, right? This is what we get. Okay. Now, we had already area of triangle ADEV was same, right? We had taken area of ADE also. So what are we going to do now? Area of ADE, triangle ADE over area of triangle BDE equals area of triangle ADE over area of triangle CED. How did we do this and why did we do this? See, in the numerators, we have written ADE equals ADE. That is obviously same triangle. In the denominators, we wrote BDE over BDE and CED, which we just proved, right? Over here we could write therefore. Okay. Now, we will just put in the values in terms of the lines that we have done in the previous slide. So, area of triangle ADE, we have taken half into AD into EM, and area of BDE was half into BD into EM, right? Equals half into AE into DN. This is what we had got over half into CE into DN, right? So what are we getting now? We are getting EM getting cancelled, DN getting cancelled, half cancelled, right? So now we are at the verge of proving our theorem, and that gives that AD over BD equals AE over CE. This is what we are supposed to prove. Now, let's quickly revisit the whole proof. We started with, first of all, we understood that we had to prove. Then we did constructions over here. Guys, whenever we are doing any construction in any proof or any question, it is necessary to write that while doing it. Okay. Then we started with the proof. And in the proof, we figured out first the area of triangle ADE, considering AD as your base and then AE as your base, right? After that, we found the area for triangle BDE and then CED. Okay. Then came very important theorem which is necessary to prove BPT. The theorem said when two triangles lie between two parallel lines and are from the same base, they are equal in areas, right? So therefore, we got that area of triangle BDE is same as area of triangle CED, which we wrote over here. After that, we brought the areas in proportion because we wanted the sides in proportion. So we got areas in proportion. ADE was the same for both, and then BDE was equals to CED. So we were easily able to put them in proportion. After that, we substituted the values, cancelled out what was cancelable, and that gave us the final answer that AD over BD equals AE over CE, and hence proved. So we have proved the BPT, that is Basic Proportionality Theorem. So this was the introductory session for triangles, and soon we will be doing video on the converse of BPT and the relevant questions. Happy learning!